Today we're going to talk to you about Kind. This is basically an effort to make local Kubernetes development easier, more lightweight. A lot of people for years have been using Minikube, and while it is absolutely wonderful, and that tool is heavily used by many people, Kind is a little bit more lightweight because it doesn't require a huge ISO, and it doesn't require as much of a memory footprint. Kind stands for Kubernetes in Docker, and it basically just uses containers to run a Kubernetes cluster. So today we're going to do a few things. We're going to install Kind using Brew. I'm doing this on a MacBook Pro. You can do the same thing on a Linux machine. I'm unclear about Windows, but then again, it's Windows. I don't care. So we're going to install Kind. We're going to create a cluster. We're going to deploy the dashboard and all the admin user and role bindings, so that we get some good visuals on our cluster. Then we're going to run a deployment. We're going to do just an Nginx deployment with a couple of pods, and then we're going to expose the service locally on our machine and sort of start to understand some of the things that we have to do to get to run our application running on a local Kubernetes cluster. So without further ado, let's get to it. So we're going to do a brew install Kind. This is pretty quick. I was shocked at how fast this can be. Now I'm doing this on a 32 gig MacBook Pro. You can do the same thing on an 8 gig MacBook Pro, which I have done. In fact, I originally developed this tutorial on an 8 gig MacBook Pro. So now we've got Kind installed. And as per our instructions, we are going to create a cluster. Now, when you do this, when you don't specify a name of our cluster, Kind just creates one called Kind with one node. It's just a control plane and the ability to deploy to it. That's fine and good, but it's unrealistic in terms of our Kubernetes footprint. Any normal Kubernetes environment that we're going to be developing on or deploying to is going to be a control plane or master node and then worker nodes supporting it. So sorry, here we go. Nodes. So here we've got our one node. Now it's not ready yet. It takes a minute to come up fully, and I use kube context to view where my kubectle's looking at. Okay, now our control plane's ready, so we can we could see that okay, everything's up and running and great, and we could say Kind get clusters, what's running and where. This isn't a realistic configuration. So what we're going to do is we're going to delete this guy. Now, if I didn't specify the name, it still would have deleted Kind because Kind is the default name for a cluster. So now if I do get clusters, we don't have any. Okay, fine. So what we're going to do is Kind create clusters. And I've got a config file as as part of this repo that just says, hey, so now you can see we're going to have a master node or a control plane node and our worker nodes. There's going to be 3 of them. So it's going to take a little longer to set it up, but it's very, very quick. What's also great about this is you could do things like experiment with service meshes, Istio. I found that when you run this on a MacBook with an 8 gig RAM spec running Istio, I ran out of memory. The whole cluster froze up. In fact, the whole machine froze up. So that might not be your case, but I recommend doing something with either 16 or 32 gig, which for a development environment I don't think is a lot to ask. A couple other things. There's a little website with all kinds of best practices and details. Here's, how you can install. Oh, you can install on Windows. Oh, fantastic. Yeah, good stuff. So, you've got a lot of detail here. The team that's putting this together, I really like these guys, and they're very active in the community. So I think it's something that, as an organization or an enterprise, you can rely on. Okay, so we're up, we're running. Let's just take a look. Now we've got our control plane, our worker nodes, and we're up and running, but the last guy isn't quite there yet, so he's going to need a minute. Oh, there we go. Now all our nodes are up and running, and let's just clear this. And, the footprint looks pretty much the same. Okay, so next up, let's get our dashboard deployed so we can get some visuals. I'm a very visual person, so I try to get that going. And then we're going to, and I don't want to get into the details of the dashboard itself or users and cluster role bindings. That's a different kind of fox hunt altogether, but basically by running all this, we're creating a situation where we've got the dashboard, it's running with the appropriate permissions, and we're going to be able to access it. Run kubectl proxy, so we can proxy into the dashboard, but then we're going to use token authentication, so I'm going to have to get the token, which is a secret held for the admin user that we created. So paste it in here. All right, we're in. We've got our different namespaces running. Fantastic. No pods because we haven't deployed anything yet. But if we looked at, Cube System, we'd see a bunch. Fantastic. Here's our nodes. All right, we're in business. So now, this is all really exciting, right? We've got our different containers running. We've got everything's up 100%. Fantastic. But we haven't deployed anything. And, this demo really wouldn't kind of be helpful unless we deployed something and saw how all that went down. So, without further ado, we're going to deploy our Nginx. And we're in container creation mode. This takes a second. Oh, we're up and running. Good stuff. And we've also got this as a deployment. There we go. Now, also notice that both pods are on the first worker node. We could play around with all kinds of label selection and infinity and anti-infinity, but that's beyond the scope of what we're trying to do here today. But in our deployment, we've got 2 of 2 pods for the deployment running. Fantastic. So our next step is we're going to expose our deployment to a service, which if you're familiar with Kubernetes, you know that that's pretty much part of the process at some point or another. We're using a type node port because unless we do some fancy footwork or networking, to be specific, we're not going to have type load balancer. Okay, so we've got our deployment exposed as a service. And here we go. There's our service right there. We're using a node port, not a cluster IP. This is mapping to 80, obviously, because Nginx runs default on 80. But we still can't get to it, right? It's not like we're going to run localhost to get to it. So next thing we're going to do is we're going to port forward port 8000 or some other arbitrary port For me, it's 8,000, but you could put anything. As long as you're not having anything else run on 8,000, it'll work. We're going to proxy, we're going to do a port forward into this particular application. Boom. There's Nginx. We're up, we're running, we're taking traffic. It's real all exciting. And we did this all in a couple minutes. So this is basically setting up a cluster locally and getting it to run. You know, this way you're not setting up all kinds of you know, clusters with cops on a 4Pay environment. You can do your development locally on Kubernetes. You could, in later videos, I think we'll deploy some stateful applications like Postgres or MySQL using Helm. We'll get Helm charts in this, but you can also use things like service meshes. So you can install Istio if you want to play with that, which I highly recommend because that's pretty much going to be, if not already, one of the service mesh industry standards. So in under 12 minutes, we've got a cluster up and running. We've got pods, we've got deployments, we've got services, we have the networking so we can see our application. Now, just to clean this up, we're going to do a kind get clusters, okay, and then we're going to do a kind delete cluster. And because we're not using the default name, we're going to use the regular name, like the name that we provided. And this way you don't have to tear down like all the services and deployments and pods. Okay, and as you could probably imagine, we go to this guy and she gone. All right. And this stuff's all going to error out because it doesn't exist anymore, right? Our connection to the pod got lost when we were port forwarding to it. And now our environment